All right, we're going to start with a warm-up question here, and that goes back to trigonometry. So what I'd like you to do up here is write down the mnemonic device we have that helps us with trigonometry. Remember, that's usually when we're using sides and angles to find things. So hopefully you've written that down by now. So that is SOHCAHTOA. SOHCAHTOA. So, and you can write that, when you're taking a test, you can write, once the teacher hands you a test, you could write that on the top of the test or whatever. So, now, we're trying to find this angle, and we're looking at this side and this side. So for this angle, this is the opposite, and this is the adjacent. So that's O and A. So we think about SOHCAHTOA. We also like to practice just thinking from memory. So O and A, TOA, that's TOA. That's this one right here, O and A, TOA. So we're using tangent. So we're going to say the tangent of x equals the opposite over the adjacent. So that's 11 and 9. But we're actually trying to find an angle. So if you recall, when we're trying to find an angle, we actually use the inverse trig function. So that's going to be inverse tangent. It looks like we're taking it to the -1 power, but that's not what we're doing. It's just a context clue, is how you know if that's a negative exponent or if it's an inverse symbol. So the more you work with it, the more you get used to it. So that's it. We're done with that one. Okay. Now if we move over here, now we have two variables over here, so I guess we can go in alphabetical order. So we want to look at the two things that we have and the thing that we want. So that is adjacent and hypotenuse. Adjacent and hypotenuse. So you should think to yourself, adjacent hypotenuse, AH, which one has A and H in it? Ka. So cosine of 57 degrees equals the adjacent side over the hypotenuse. And we talked about basically what we could do is just switch these two. Now, that's not really what's happening. What's happening is we're multiplying both sides by W, and then this one cancels, and then we're dividing both sides by this. But the result, what we end up with, is the same thing we would get if we just switched those. Okay, now if you're doing an ALEX, they may have you type that in your phone or your calculator and get the decimal. But in class, we just have you leave stuff like that. We don't use the calculators too much. Okay, and so finally, here we want to find Z. So that's opposite. So don't use the new stuff. Always use the old stuff because that's more accurate. So as far as what's in this problem already. So this is opposite and adjacent. So opposite and adjacent, OA, that's tangent. So the tangent of 57 degrees equals the opposite over the adjacent. So if we multiply both sides by 14, we get that. Okay, so that's some review, and some students have a hard time with that, so that's why we have it in the review to emphasize it. Okay, so a couple things here. Central angle. We skipped chapter 10, but if you need to see some more about chapter 10, about central angles, you could go back to chapter 10. But it's pretty simply an angle with its vertex at the center of a circle. So if we look down here, here's a central angle, angle JNK, and angle KNL. That's a central angle also. Okay. The measure of an arc equals the measure of its central angle. Okay, and we have major and minor arcs. A major arc is more than 180 degrees, or 180 or more, and a minor arc is less than 180. Okay, so we start over here and we find the measure of the arc. So find the measure of each arc. So arc JK. So it says that an arc is equal to the measure of its central angle. So the central angle here is 41, so the measure of the arc would also be 41 degrees. That's that simple. Okay. If we move over here to arc JL, arc JL is out here, that would just be that plus that. So that's going to be 41 plus 69. So that's 0, carry the 1. That's going to be 110 degrees. All right. And if we move down here, and now a major arc always has to have 3 letters, because we couldn't just say arc JK, because if we said arc JK, does that mean all the way around here, or does that mean here? Well, the way we can tell is that for it to be all the way around here, there has to be 3 letters. If it's 180 or more, there has to be 3 letters. So JML tells us we're going all the way around there. We could highlight that as well, I suppose. All the way around there. Now, what would be the easiest way to do that? There's a couple different ways, but we already added these two together to get 110, and that would be the rest of the circle. So if you think about it, all the way around would be 360. The part that we're not using is 110, so if we subtract that, that's going to be 250 degrees. And because it's a major arc, we know that this should be 180 or more. Okay. And finally, JMK. JMK is all the way around here, so it's everything except for this green arc. So that's kind of similar to what we just did. We're just going to take 360 minus 41. So that's going to be 9. Borrow off of here. 5 minus 4 is 1. So that's going to be 319. So hopefully you are feeling pretty good about this lesson so far. So that's just kind of some background information. And we also need to know that the circumference of a circle is 2 pi r. Now maybe a lot of us realize that 2 radii, 2 r's, are d. So that's another formula for it, but we like this formula better because the area formula of a circle also uses radius. And so we usually focus on the radius because it works in both formulas. All right. Pi, Greek letter pi, they still use that letter in Greece today. It's one of the letters of their alphabet. Pi is the ratio of the circumference to the diameter. So that's the exact value of pi. Now, approximately, pi is approximately 3.14159265358979323. I used to know it out a ways, but I don't want to use up your time, so I don't know how far I remember it to. I haven't written it down in a while. Okay, so let's move on to example 1 here. So far that was all kind of review. Technically, although I don't remember when we talked about that. Maybe it was in chapter 10, but we haven't done chapter 10 yet. So let's just go back to here. So solve for a stool with a circular seat. Find the circumference of the seat if the radius is 9 inches. So that's something you've probably done for quite a few years now, finding the circumference of something. So the circumference is 2 pi r. Okay, so again, this is pretty nice stuff so far, as far as not being too complicated. So that's pretty nice. Okay. So if we come back to here, the radius, if the circumference is 52. So now we're going to say 2 pi r. And they do throw in the diameter sometimes, so you want to make sure you are careful about that. And maybe if they give you the diameter, you might want to divide it by 2 to get the radius, but there are some different situations there. So we're trying to get r by itself, so we're going to go ahead and divide by 2 pi right now. That may make you feel a little uncomfortable, but this reduces, they're both even, so we can divide by 2. So that's going to be 26 over pi inches for the radius. And that's 3.14, so 27 divided by 3 is 9, so it's going to be a little bit less than 9. Okay, so we're just going to move right along here, and we just have one more page. Arc length. So there's a difference between arc measurement and arc length. Arc measure, okay, is in degrees. Arc measure, that's what we were kind of looking at before we did circumference. Arc measure is in degrees. Arc length is in linear units like inches or centimeters or feet, etc. Okay? So, the main way we look at this is setting up this proportion. And 360 is always right here. These things can vary depending on what we're looking at. So this is always solid. Now, another way to look at this is if we take both sides and multiply by c. So we can also have that the arc length is equal to the arc measure over 360 times the circumference. And if you think about it, the arc measure divided by 360, that's the fraction of the circle that we have. Okay? That's the fraction of the circle. So if the arc measure was 180, 180 over 360 is 1/2 because we have 1/2 of the circle. So that is another way to look at it, although generally I try to set up the proportion first. So find the arc length of JK right here. So how do we do that? So the length of the arc is this, so I'm going to call that A for arc length. So I need to divide that by the circumference. The circumference is 2 pi r. And then I need the arc measure, which is 60 over 360. Okay? So if we reduce that, that reduces to 1/6. And we can multiply both sides by 2 pi times 16. Okay? So this reduces to a 3, and so we could say 16 pi over 3 inches is how long that arc is. Now we can approximate that because pi is 3.14, so this is a little bit more than 1, so it's going to be more than 16, maybe 17, somewhere between 16 and 17. So hopefully sometimes we can kind of get a rough idea of what we have. Okay, so now let's see, now we want to find the measure of arc LM. The measure of arc. So what we're trying to find is this right here. So I'm trying to find the measure of the arc, the degrees. So we have the arc length. If you want to set it up the same way here, usually I try to keep the variable in the top left, but if we set it up just the way it is here, this would be 16.76 over the circumference, which is 2 pi r, equals the measure that we were just talking about over 360. Alright, so if we multiply both sides by 360, we would have 360 times 16.76 over 2 pi times 8. Okay, so if we start reducing that fraction, 2 goes into 360 180 times, and here I think I can divide these both by 4, or maybe I should go by 2. So if I divide by 2, that's 4, and if I divide that by 2, that's 90. If I divide this by 2 again, I get 2, and if I divide that by 2 again, I get 45. Sorry, 45. Okay, so now I have 45 divided by 2. So 45 divided by 2 is 22.5 times 16.76 over pi. And that's an angle measure. So that would be fine in our class because we're not using the calculator, but if we are doing this on Alex or in our textbook, we need to check the answer, we would do that on the calculator. It turns out to be 120 degrees, basically. Pretty close. Alright. And let's go here. So now they're asking us to find the circumference. Alright, I'm going to just fill it out the way it was. So the arc length is 10.2. I'm not excited about this because the variable's in the denominator, but there's things we can do about that. This is 45 degrees, and that's going to be over 360. Okay. I guess we'll just leave it like that. So first of all, I would reduce this. So 45, actually if you think about it, 45 times 2 is 90, and 90 goes into this 4 times. So maybe you can figure out that goes in 8 times. So if you want to reduce that, that's 1 over 8. Now we can do is cross multiply. So we're just going to get c times 1, which is c, and 8 times 10.2. So I guess I'll write that out, but we probably can do that in our head. So that's going to be 8 times 10 is 80, and 8 times 0.2 is 1.6. So it's going to be 81.6 centimeters. Okay, now we're down to our last question. It is a little bit cumbersome, so let's just get right into it. So we'll look at tire A in purple and tire B in blue. Okay, you don't have to do it in purple and blue. That's just what I have handy here. So, okay, so I'm gonna look at tire A first. So tire A. Okay, so 2 different bicycle tires are shown. How many revolutions does each tire make while traveling 25 feet? Well, the first thing we should do is probably figure out how far does this tire go when it goes around once. Well, if you think about that, if we put a dot on here and then we rolled it around until it got back to that dot, that would be how far it traveled, and it would match the length around the circle. So it's the same as the circumference. So the circumference of the circle tells us how far the tire will travel in one rotation, one revolution. So that's going to be 2 pi r. And you got to be careful here. So this r is, the spoke is 5 inches, and the width of the tire is actually 1.5 inches. So we need to add those together to get 6.5 inches. Okay. So if we multiply that together, we get 12, we get 13. So that's 13 pi, which would be over 40, something a little bit over 40 inches. So that's the circumference. Now, if we take the total distance, 25 feet, and we divide that by 13 pi, and if we look at that, that's going to be inches per revolution. Okay, so the first thing we need to do is kind of get those units to be the same relationship if we were trying to find out how many times the tire is going to go around. So really what we want is we want to cancel out inches and we want to cancel out feet. So we want to think, what's the relationship of inches to feet? There's 12 inches in 1 foot. So what that's going to do is cancel that out, and it's going to cancel this out. Okay, so if we multiply this together, 12 times 25, that'd be like having 12 quarters. So if you had 12 quarters, and maybe by the time you guys have kids, they won't even use change anymore. Maybe everything will be on our phones and electronically. But for now, I think you all hopefully know what a quarter is. So if we had 12 quarters, we would have $3. And so actually that would be 300 pennies in this case. 12 times 25 is 300. So we have 300 over 13 pi revolutions. Okay? If you think about it being a complex fraction, we could multiply by revolutions over revolutions, and down here that would equal 1. Or you could do multiply by the reciprocal if you want. Anyway, so in class that would be fine, but we probably, some of us maybe are curious what that is actually. So that would be 7.346 revolutions. It would go around a little less than 7.5 times. Alright, so now we're going to look at tire B. And so we're also going to need to look at the circumference, and that's going to be 2 pi r. And in that case, it's 8 plus 2, so it's 10. So that's going to be 20 pi inches. Okay, so hopefully if we think about this a little bit, should this tire have to go around more times or less time to cover 25 feet? Okay, so the answer to that should be less because it's bigger, so it's going to go farther each time it goes around than that will. Okay, which actually relates to what you kind of tires you put on your vehicle. When you put smaller tires on your vehicle, they're going to go around more times to cover the same distance. So that's going to affect your odometer, your mileage, and that impacts when you sell your car, how many miles it has on it. A car with smaller tires is going to have more miles on it, I think. That's how that works, unless they make adjustments. I don't know. I don't think they make adjustments to that. But now, having a huge tire on your car, that actually causes, that's a lot heavier, and so that would reduce your gas mileage and stuff. So there's a lot of things to consider with those choices. Okay, so we're back to 25 feet, and the question is how many times will 20 pi inches per revolution, what would that give us? So again, we have 12 inches in 1 foot. So again, those cancel, and this is going to come up there. So we can also reduce here. So 4 goes into here 3 times, and 4 goes into here 5 times, and 5 goes into here 5 times. So that looks like we're down to 15 over pi. 15 over pi revolutions. We don't really like to use the slash as a fraction, but that's what I did there. So, and that's approximately 4.77 pi revolutions. And that's what we said. The bigger tire should have to go around less times to cover the same distance as the smaller tire. Okay, it's about that time. That was nice, short and sweet. So have a good day. It's about that time. Go do a math assignment.